Factor each of the following. First, factor out the greatest common factor, or GCF, of all terms in the expression. Once this is done, if you get an expression of the form x squared plus bx plus c, we have to look for two numbers. We'll call them p and q, such that p plus q equals b and p times q equals c. If this is not possible, then the expression simply is not factorable. If it does work, then the factors are x plus p and x plus q. For an expression of the form a squared minus b squared, difference of two perfect squares, the factors will always be a plus b and a minus b. The a plus b and a minus b are called conjugates of each other. Note that the binomials differ only by the sign separating the two terms. For the first question, we first have to factor a 2 out of the entire expression. When we do this, we're left with x to the 4 plus 9x squared plus 18. We are then looking for two numbers that add to give 9 and multiply to give 18. These numbers are 6 and 3. We can then say that our factors are x squared plus 6 and x squared plus 3, giving a total factored form of 2 times x squared plus 6 times x squared plus 3. For the next question, we're looking for two numbers that add to give 6 and multiply to give 8. In this case, those numbers are 4 and 2. We then write the expression as x plus b plus 4 and x plus b plus 2. Note that if you prefer, you could substitute another variable in place of the x plus b, and then at the end, replace it back with the x plus b. Simplifying this a little bit, we get x plus b plus 4 times x plus b plus 2. For the next one, here we have a difference of two perfect squares. We simply take the square root of each of them, and then one of them we add, the other one subtract. The square root of 36x squared is 6x. The square root of 49 is 7. For the next one, we first have to factor out the common factor of 3a. Once we do that, we're left with a squared minus 4b squared. Note that the a squared minus 4b squared is another difference of two perfect squares. We can simplify that then to 3a times a plus 2b times a minus 2b. For the next question, we have another difference of two perfect squares. In this case, the square root of 81a to the 4 is 9a squared, and the square root of 16 is 4. Notice at this point, however, that one of the factors can be further factored. 9a squared minus 4 is another difference of two perfect squares. The 9a squared plus 4 has to be left the same, but the 9a squared minus 4 can be rewritten as 3a plus 2 times 3a minus 2. Our final question here, again, we have a difference of squares. Here, the first square has a square root of x plus 3, and then for y squared, the square root is y. We then have x plus 3 plus y and x plus 3 minus y. Again, we can simplify this a little bit to x plus y plus 3 and x minus y plus 3.